Hello everyone. Today our presentation is a continuation of the topic thermal physics, part 2 of 2. Without further ado, let's get into it. Melting and boiling. Melting from solid to liquid and boiling liquid to gas. As heat energy is applied to a substance, its particles absorb this energy and use it to overcome the intermolecular forces that hold them together. During this phase change, the temperature remains constant even though heat is continually added. This is because the added heat energy is being used to increase the potential energy of the particles and overcome the forces holding them together, not to increase their kinetic energy. Once the phase change is complete, the temperature starts to rise again. Kinetic and potential energy. The kinetic energy of the particles does not increase during the phase change. Instead, it remains constant. Meanwhile, the potential energy of the particle does increase as they become less tightly bound to each other. This increase in potential energy results in the change in the arrangement of the particles from a solid to a liquid or from liquid to a gas. While the temperature remains constant during the phase change, it does change before and after the phase change occurs. Let's look into the condensation and solidification. Condensation is a phase transition in which a gas or vapor changes into liquid. And this process occurs when a gas loses thermal energy, usually by coming into contact with a colder surface or as a result of the decrease in temperature. Formation of droplet happen when water vapor in the air loses energy and cools down. It forms tiny water droplets. This is a process responsible for the formation of clouds in the atmosphere and dew on grass in the morning. During condensation heat, it releases as the gas particles slow down and become more ordered in the liquid phase. The heat release is responsible for warming the surrounding. Example for condensation is include formation of water droplets on a cold glass of water, or the creation of fogs, or formation of rain in the atmosphere when water vapor in the clouds condense into liquid droplets. Solidification. Solidification is a process in which substance changes from a liquid or gas phase to a solid phase. It occurs when a material loses heat energy and transitions from a more disordered state, liquid or gas, to a more ordered rigid state, which is solid. Example for solidification will be freezing. Solidification often refers to freezing when it's involved the transformation of a liquid to a solid. Crystal formation. During solidification, the particles in the substance become more closely packed and they arrange themselves in a regular, repeating patterns characteristic of a solid phase. Or the example is heat release. Similarly to condensation, solidification also releases heat. The heat that was initially added to the substance during melting or vaporization is released as the particles slow down and become more ordered in a solid space. Differences between boiling and evaporation. Boiling is a rapid phase transition that occurs when a liquid reaches its boiling point. which is a specific temperature for each substance. It takes place throughout the entire volume of liquid, and boiling is a bubble of gas formed within the liquid and rise to the surface. Boiling required a constant and external heat source to maintain the required acid boiling point. It is typically used for cooking, sterilization, and other processes that require a rapid and controlled change from liquid to gas. Meanwhile, evaporation is a slower phase transition that occurs at the surface of a liquid when individual molecules gain enough energy to escape into the gas phase. It can occur at any temperature as long as there is sufficient heat energy for molecules at the surface to evaporate. There are no visible bubbles during evaporation, and it is a gradual and continuous process. Evaporation absorbs heat energy from the surrounding, which can lead to cooling of remaining liquid. It is responsible for the drying of wet surfaces, such as clothes drying on a line or the formation of dew. Latent heat. Latent heat refers to the amount of heat energy that is either absorbed or released by a substance during a phase change without a change in temperature. Two types of latent heat is latent heat of fusion and latent heat of vaporization. Latent heat of fusion is the amount of heat energy absorbed or released when a substance changes from a solid to a liquid, or vice versa at a constant temperature. When a solid melts to become a liquid, it absorbs heat energy, which is the latent heat of fusion. When a liquid freezes to become a solid, it releases heat energy, which is also the latent heat of fusion. The latent heat of fusion is specific to each substance and is usually expressed in joule per gram or calories per gram. You can see the formula to calculate the latent heat of fusion is Q represent heat energy in joule, mass M represent in kilogram, and LF latent heat of fusion is joule kilogram. So Q is equal to MLF. Latent heat of vaporization is the amount of heat energy absorbed or released when a substance changes from a liquid to a gas. Meanwhile, latent heat of fusion is a substance changes from a solid to a liquid. Okay, refer to the latent heat of vaporization. So, is a substance changes from a liquid to a gas or vice versa at a constant temperature. When a liquid vaporizes to become a gas, it absorbs heat energy, which is the latent heat of vaporization. When a gas condenses to become a liquid, it releases heat energy, which is also the latent heat of vaporization. Latent heat of vaporization is specific to each substance and is usually expressed in joule per gram or calories per gram. The formula is the same, except L is represent latent heat of vaporization. Transfer of thermal energy. Meaning transfer of thermal energy is the transfer of thermal energy consists of three different methods: conduction, convection, and radiation. Conduction is the transfer of heat through direct contact between particles in a solid material. It occurs when high energy particles collide with adjacent lower energy particles, transferring thermal energy, and this process continues until an equilibrium is reached. Example, if you place one end of a metal rod in a flame, the heat is conducted through the rod, making the other end hot. Convection involves the transfer of heat through the movement of liquid or gases. When a portion of a liquid is heated, it becomes less dense and rises, while cooler, denser fluid flows aim to take its place. This creates a continuous circulation of fluid transferring heat. Example, when you boil water in a pot, it demonstrates convection as hot water rises and cooler water moves it to be heated. Meanwhile, radiation is a process of transfer of heat through electromagnetic wave. All objects emit electromagnetic radiation in the form of infrared wave due to their temperature. Although objects emit more radiation, heat is transferred when this radiation is absorbed by another object. Example is the sun radiates heat in the form of sunlight, which travels through the vacuum of space and heat the earth. Application of heat transfer. Example conduction process is a frying pan of food, convection to boil water, radiation in the oven device to heat up food. Common devices like heat sensor, refrigerator, air conditioners utilize one or more heat process. This is a vacuum. It's a vacuum, or we can say that it's a thermos. This is an example where it consists of conduction process, convection process, and radiation. Let's look what are the materials inside or uses in the thermos. For example, like cap or stopper is for use of airtight seal, is to prevent air from entering. Vacuum, okay, the function is the space between the double glass or metal wall of the glass is a vacuum, is to devoid of air. Like silver surfaces is a good reflector of infrared radiation, which is helped to reduce heat loss. And double glass shell is a metal. Double glass shells type metal. This minimizes heat conduction, keeping the content hot or cool for an extended period. And casing act as an additional barrier against heat transfer through conduction and convection. With that being said, I would like to end my presentation and hope you really understand with the topic that we have discussed today, and hope you are enjoying studying and understand all the subject in this lecture. And that's all for today, and hope to see you in the next presentation. And by the way, please don't forget to subscribe to Mr. YouTube channel. Thank you very much.